Hi all! In this video we're going to talk about objectives 1 through 3. So we're going to simplify fractional exponents, then we're going to talk about degree and evaluating power functions, then we're going to talk about even, odd, or neither. So that's what this video is going to entail. So objective 1, we're going to simplify the following terms so we can simplify fractional exponents. So let's do it. 27 to the 4/3. And you can type this into a calculator, but this is kind of to develop our number fluency skills. So I'm not going to use calculator. So 27, well, we'll see actually. 27 to the 4/3 is the same as taking the cube root first. So we can take it to the 1/3 power and then take that to the 4th power. That's one way you can write it. If you don't want to write off this step if it's confusing, if you just know I can take the cube root first and then take it to the 4th power, then just write that out. So 27, cube root of 27. So we know that 3 times 3 times 3 is 27. So that means the cube root of 27 is 3. Ooh, 3 to the 4th power. 3 times 3, 27, 81. Wait. Oh, that would be 81. All right. We don't need calculators. Is that correct? How can we ever check it? Oh, wait, we do have access to calculators. 27 to the... Oh, no, what was it? 4/3. 4/3 is 81. Hey, nice work. All right. Let's do the next one. 8 to the negative 1/3 power. All right, y'all. If you go to the book pages assignment, I have a meme about Patrick, and it takes all the negative... It's like, takes all the negative exponents and put them down there. So we're going to put these negative exponents in the denominator. So 8 to the negative 1/3 is the same as saying, oh, goodness, 1 over 8 to the 1/3 power. Remember that 1/3 is the same as a cube root. So what multiplied by itself 3 times equals 8? You guessed it, that is 2. So this is actually just 1/2. Whoa. I guess I could write out that step. This is 1 over the cube root of 8, which is 2. So you end up with 1/2. All right. And then this last one, 100,000 to the 4/5 power. So I suppose you might be noticing that for a lot of these, I will first deal with this denominator exponent, so the 5th, like the 5th root, and then I will deal with the numerator. And that's just so that instead of the numbers getting very, very large and then dealing with the 5th root, I can make them smaller and more manageable first, and then bring it up to a higher number with this numerator. And that's my reasoning, if that makes any sense. It's just to deal with smaller numbers sooner. So 100,000 to the 4/5 power, that is the same thing as taking the 5th root of 100,000. 100,000, and then taking that to the 4th power. So we need something when multiplied by itself 5 times equals 100,000. Notice how many zeros we got on here? This is 10. 10 times 10 times 10 times 10 times 10 is 100,000. So this is 10. So 5th root of 100,000 is 10 to the 4th power. So we're going to do 10 times 10 times 10 times 10, 10 times 10 times 10 times 10, which would be 10,000. Pretty cool. And that's it for that. So you can always double check your answers here with a calculator, but this is, again, to promote fluency, like in number sense. Right. All right, this, determine the degree and evaluate power functions. You know how to evaluate power functions. You plug in 8 for x. So the degree, remember, we talked about this last week, but we'll go over it. So the degree is just the highest exponent attached to x. This only has one exponent because we're dealing with power functions. This will come up again as we talk about polynomials in a week or two. So if this had been 2x cubed minus x squared minus x minus 1, the degree of the polynomial, or the degree of the power function, is always just the highest exponent. So for us, that's this 3. So the degree is 3. Another thing that will come up that we'll talk about, that we talked about last week, is the leading coefficient that I'm going to talk about now. And that is the term that has the highest power. So like the term that you got your degree from. So for us, it's just this only term. But the leading coefficient, C-I-E-N-T, coefficient? No, what? Coefficient. Okay, work with me. That's not spelled correctly, but that's okay. The leading coefficient is whatever number is being multiplied by your highest term. So for us, this is 2. And f of 8, you just evaluate it. So f of 8, plug in 8 for all the x's, equals 2 times 8 cubed. Oh, I can't do 64 times 8. All right. 8 cubed is 512 times 2 is 1,024. And that's it for that objective. Last one. Determine if functions are even or odd. You can always graph these and see where their symmetry is. I'm going to do it algebraically just to practice proofs, because this is what this is. It's just a proof. All right. So remember that a function is even if f of x, f of negative x, f of negative x equals f of x for all x. So this is like our end goal. If it's even or if it's odd, then that means f of x, f of negative x equals negative f of x for all x in the domain. So I guess I should just write this as even and this one is odd. But this isn't really applying to this problem. This is just going to be in general. So I'm just going to, I guess I probably should have thrown that in the margin. But okay, so let's plug in f of negative x. F of negative x for this x to the fourth function is negative x to the fourth. So we plug in a negative x for every x, which is just one term. And then we simplify. Keep in mind that, negative x times negative x is a positive x. Times another negative x, that's 3. That'll get you a negative x. Or that'll get you like a negative value, but then times another one, that brings it back to the positive value. So this term will always be positive because we're multiplying 4 of them, even if it was a negative term initially. So this is the same as x to the fourth, which is equal to f of x. So f of negative x equals f of x. So this guy is even. And you could have graphed that and seen that visually as well. Now, this other one, let's go ahead and plug in f of negative x for every x. So we're going to end up with 2 times negative x cubed minus 4 times negative x. Let's simplify. All right, negative x cubed. Negative x times negative x times negative x. That's still negative x cubed. So this is going to become negative 2 x cubed. If you can see what I did here, I just moved that negative outside of the term. So this term becomes negative. and then minus 4 times negative x, that becomes a plus 4x. Okay, I'm going to do something goofy, and I'm going to factor out a negative. So I'm going to factor out this negative, so I'm going to take a negative away from both terms. So this is going to become a 2x cubed, and then this is going to switch to be a 4x. Remember that factoring is the opposite of distribution, so I just pulled out this negative. So I can always distribute this back in. So negative 1 times 2x is going to bring this negative 2x, and then this negative 1 times this like negative 4x is going to make it a positive 4x. So it's just factoring is the opposite of distribution. Okay, and hey, this looks familiar. 2x cubed minus 4x, this is the same thing as negative f of x. So this took a lot, but f of negative x equals negative f of x. So this function is odd. And you might find some sort of connection with this had an even power and this one had an odd power. That's not an all-encompassing rule because when you add in multiple terms, so if I had added in like an x squared term, that might have changed things here. So keep in mind you can do this visually by looking at graphs, or you can do it algebraically, and this would be considered a proof, an algebraic proof. So that's all I'm going to do in this video. Email me if you have any questions.